Hi, good morning. I'm Mr. Chiu. In the last 2 days, I've got many messages of you through WhatsApp. I'm so happy to know that you are all doing okay at home. I hope that the school could resume as soon as possible so that we could see each other face to face. And today we're going to do revision of the chapter 9 Pythagoras theorem because please be reminded our schedule, our timeline. So today is 26th of March. Today is a Thursday, so that we are going to do a revision together. So that yes, you have a homework today to do today. Today you're going to do worksheet, the last one of chapter 9, which is worksheet 11. It is a revision exercise. So in this video, we are going to do the revision together so that you will be able to do this revision exercise and you have the idea of how the quiz looks like. So that tomorrow, please hand in to me 27. So tomorrow, Friday, so hand in the worksheet 11. All right? And then you could be well prepared for the quiz, which will be on Saturday morning. I will give you a quiz paper of chapter 9, Pythagoras theorem. Okay, on Saturday I will give you the quiz paper on the Google Classroom. You could just do it on a paper and then you take a picture and then hand it to me. Okay, so you have to hand it to me within Saturday. Do not be later than Saturday, midnight. And then on Monday, so it is 20, so in the coming Monday, and then Wednesday, and then Friday, next Monday, Wednesday, and Friday, we're gonna have an online, using Zoom to do an online classroom, 10 to 10:45. So using Zoom to conduct the next chapter. All right? So this is our timeline. And now let's begin to do the revision, the overall revision of chapter 9, Pythagoras theorem. So chapter 9 is a very short chapter. It's all about a very famous, very useful formula called Pythagoras theorem. Pythagoras theorem. In this chapter, there are just 3 things to learn. The first one, of course, is about the Pythagoras theorem. It's about Pythagoras theorem. And then the second one is the opposite of Pythagoras theorem. So we call this the converse of Pythagoras theorem. And then in this chapter, there's one more thing, which is about how to simplify a third. Simplify a third using short division. Okay? So there are only 3 things that we've learned in this chapter. And in the coming quiz on Saturday, we will be focused on Pythagoras theorem and also the converse of Pythagoras theorem only. Now, let's do the revision. What is Pythagoras theorem? Do you still remember? So let me write down the topic. Pythagoras theorem. Okay, number 1. What is Pythagoras theorem? Pythagoras theorem. Have you got any idea? When can we use the Pythagoras theorem? In a triangle? Just a triangle? Not just a triangle, but it has to be a special one. And that triangle must be a right angle triangle. So if we have a right angle triangle, is it a right angle triangle? No, it is a right angle triangle if and only if there's a right angle here. So if I give you one more information, I tell you that this angle is a right angle, then this is a right angle triangle. So that there are three sides, so I just name them as A, B, and C, okay? If this is a right angle triangle, Pythagoras theorem is the way to link up the three sides. How do we link them up? The relationship is that the longest one, we have a name. For these three sides, they have a name. So one of them is very special. It is always the longest one, which is the one oppositing to the right angle. So do you remember how do we call this side? It has a special name, start with H. Yes, hypotenuse. We call this the hypotenuse. This one is the hypotenuse. This one always is the longest one among all the three sides. And this one must be the one oppositing to the right angle. We call this the hypotenuse. And then what about these two? How do we name these two sides? Remember the name, start with L? Yes, leg and leg. We call this leg, and this one is the leg. So, the requirement if you want to use Pythagoras theorem, there is a constraint. We need to, first of all, we need to know that it is a right angle triangle first. It is a right angle triangle. Right angle triangle. If it is a right angle triangle with a right angle here, yes, we could use the Pythagoras theorem. And we know that the hypotenuse square must be equal to the sum of the legs square. Legs square and legs square, add them up, the sum of the legs square equals to the hypotenuse square. And this is what we call the Pythagoras theorem. So that we don't need to write the full name every time. We could use the abbreviation. So Pythagoras, we could use PYTH dot. PYTH dot stand for Pythagoras. And then theorem, we could use THM dot. So this is the short form, Pythagoras theorem. Okay? And now, let's look at some examples. So number one, just look at this. Okay, we have a triangle here, and we know that this is a right angle. Do you see that? There's a right angle here. So it is a right angle triangle, and therefore we could use the Pythagoras theorem. We have to do what? We have to write down the relation between the sides. So can you use Pythagoras theorem to write down the relationship of the three sides? Okay? So which one is the hypotenuse? The one oppositing to the right angle. So this one is the hypotenuse, and therefore these two are the legs. So the Pythagoras theorem starts from which one? The legs or hypotenuse? Hypotenuse, Z square. The square of the hypotenuse equals to the sum of the legs square, so which is x square and y square. Okay? And we call this the Pythagoras theorem. Alright? So number one is done. You just need to link them up using Pythagoras theorem. So to set up the equation. And now look at number two. So you have to find the unknown of this triangle. Look at this triangle. Is it a special triangle? Yes. You see the right angle, right? So we are so happy. It is a right angle triangle. We could use the Pythagoras theorem to link this information up. So where to start? X, 24 or 25, which one? we must always start from the hypotenuse, the one opposite to the right angle. Not this one, because you see that 24 is touching the right angle. They're next to each other, so this is not the hypotenuse. X is also next to the right angle. They touch each other, so that this is not the hypotenuse. Only this one, apart from the right angle, they are not touching each other, so that this is the hypotenuse. Okay, so you should start from 25 square. Hypotenuse square equals to the sum of the legs square. So x square plus 24 square. Okay? So whenever you are using Pythagoras theorem, you write down the relationship, please put it down. What are you doing? What is this? Why? Because this is according to the Pythagoras theorem. Okay? And now, it's not done yet. You have to find the unknown. The unknown is x. You have to tell people what is x. So are you able to continue? First of all, 25 square. What is 25 square? Using calculator, 25 to the power of 2. What is that? 625. Is equal to x to the power of 2 plus, what about 24 square? 24 square is 576. So that we have 625 equal to x to the power of 2 plus 576. Now, do you remember what do we do next? We have to put all the like terms together. So these two are just a number. We could put them together. They are like terms. You could combine them. So what to do? Do you think that we could put this term, positive 576, to the left-hand side? And it will become what? Negative 576 is equal to x squared, right? 625 minus 576 is 49. So that we have 49 equal to x squared. Is it done? Is it finished? X squared equal to 49. And then you should continue. You should continue. Because you have to tell people what is x, not x squared. Do you think that you could get rid of the square? When you move the square to the other side, it becomes what? So 49 equals to x squared. When you try to move the square to the other side, it becomes a square root. So x equal to square root of 49. Square root of 49. Oh, this is nice. It equals to 7. So that we know that x equals to 7. And this is the value of the unknown x. So we finished. So we stop here. Okay? So let's draw a line to separate the two questions. Now, there's one more. Let's try to do this. For this triangle PQR, oh, this is a right angle triangle. Do you see the right angle here? Good news, we could use the Pythagoras theorem. So, which one is the hypotenuse? Is it 6 or 12 or y? Which one? Y is the hypotenuse. Do you see that? Y is oppositing to the right angle. So you should start with y to the power of 2. Y to the power of 2 equals to the sum of the legs square. 12 square plus 6 square. Okay? So are you good with the square number? Without calculator, can you tell me what is 12 square? You should memorize the square, all the square numbers from 1 to 12. So 12 square is 144. You may test, you may check. 12 square is 144. And then what about 6 square? 6 square is 36. 144 plus 36 is 180. So that we have y to the power of 2 equals to 180. Now, again, let's do the very exciting part. We want to know y, not y square. Do you think that you could get rid of the square? Bring the square to the other side, it becomes square root of 180. Square root of 180. So, using calculator, square root 180. So, it becomes, this is not very nice, so long. So let's copy down all the things. Y equals to 13.41640,786. So many decimal number is like a mess, so that you have to rewrite it in a proper way. So usually you have to give your answer in four significant figures. So start from the first non-zero number, 1, 2, 3, and 4. Okay, so we're gonna take these 4 numbers, 1, 2, 3, 4. But before that, you have to check the next number. The next number, it is 6. So is it big enough? When it is 5 or more than 5, it is big enough so that you have to add 1 to the last number. Therefore, your answer should be written as 13.40, not 1 but 2. You have to add 1 because the next number is big. When it is big, you have to add 1, and then you may ignore all the numbers that are behind. So that your answer is 13.42. Do you stop here? But you have to also tell people this answer is corrected to 4 significant figures. Okay, do you still remember all these procedures? Oh, I'm sorry, accidents. Ooh. Okay, by the way, I'm now at a classroom on the 4th floor. Now, next, number 3. In this figure, ABC is a straight line. So on a straight line, we have a right angle. Okay, so what do we need to find? We need to find the value of AB and BC. There are 2 things you have to find. First of all, find AB and then find BC. Okay, so let's find AB. Now, this is a straight line. So this angle is 90 degrees. That means the other side is also 90 degrees because you know that adjacent angles on straight line, for a straight angle, the angle size should be 180, right? If this angle is 90 degrees, then 180 minus 90 become also 90. Therefore, these 2 angles must be the same, both 90 degrees. Okay, so it is important for us because we can only use Pythagoras theorem when there's a right angle. Now, please look at one side only. Look at this triangle. Is it a right angle triangle? Yes, we've got a right angle here. It is a right angle triangle. So this is a right angle triangle. We could use Pythagoras theorem. We need to find AB, right? So you may just write AB here. This is AB. Or if you don't want to use AB, you could use X or Y. It's up to you. You can give a name for this side. So I would like to keep it as AB. Now, we have 10, we have 4, we have 8B. Do you think that you could find AB? Yes? Of course, yes, because you could use the Pythagoras theorem. So, first of all, we are now trying to find AB. How to find? Using Pythagoras. So which one to start with? Should I start with 10, AB, or 4? Which one is the hypotenuse? 10, yes, because it is oppositing to the right angle. So you should start from 10, 10 to the power of 2 equals to the sum of AB to the power of 2 and 4 to the power of 2. Okay? So this is the result of the Pythagoras theorem. Now, are you good with that square number without calculator? Can you tell me what are they? 10 to the power of 2. 10 to the power of 2 means 10 times 10, so that it becomes 100. What about 4 to the power of 2? 4 to the power of 2 means 4 times 4, which is 16. Okay? So any like terms that could be combined, yes, of course, 116, they are like terms, so put them together. 100 here is fine. I would like to keep 100 here, so we do not need to do any change. But the 16 positive, we should try to move it to the other side. So it will become negative 16. Will become just AB to the power of 2. So 100 minus 16, what is that? 84. So that we have 84 as AB to the power of 2. Any objection? Is it okay up to now? That means AB equals to, so how to get rid of the square? Bring it to the other side, becomes square root. Okay, AB equal to square root of 84. So I would like to write square root of 84. This is the length of AB. We don't need the AB anymore. You could just write square root of 84. Okay? And then after you find AB, you also need to find BC. How to find BC? Then now we should look at this triangle. And we are so happy to see that we have a right angle here as well, right? So BC from B to C, this is BC. We have to find BC, and we have 4 and 6. We have to find BC, and this is a right angle triangle. Do you think that we could use the Pythagoras theorem? Yes, because it is a right angle triangle. So that which one is the hypotenuse? 6 is the hypotenuse. 6 is opposite to the right angle. So the next part, we are going to try to find BC. And then we have to use Pythagoras. So we start with 6. 6 to the power of 2 equals to the sum of 4 to the power of 2 plus BC to the power of 2. And again, this is the result of the Pythagoras theorem. Okay? So 6 squared and 4 squared. What is 6 squared? 6 squared means 6 times 6, 36. 4 squared means 4 times 4, 16. Plus BC squared. Okay? So likewise, we should bring all the like terms together so that you should move the 16 positive to the left-hand side. It becomes negative 16. Okay, many of you forgot this step. Forget to change the sign. This is positive 16. When you move to the other side, you have to change it to negative 16. So 36 minus 16 is 20. 20 equal to BC squared. Okay, so that means BC equals to square root of 20. All right. So you have to find the value of AB and BC. So first of all, AB equals to square root of 84. But you have to give your answer in decimal number. So use calculator, square root of 84. You've got 9.1651539, which is not nice. It's a mess, so that you have to give your answer in 4 significant figures. Start from the first non-zero number, 1, 2, 3, and 4. So you're going to stop here. We're going to take these 4 numbers, but wait, you have to check the next number. Is it big enough, this one? No, 1 is not big enough. Only if it is 5 or more than 5, then it is big enough. So if it is not big enough, do we need to add 1 on the last number? No need, so that you should keep the number as 5. So that you should write 9.165. And this is corrected to 4 significant figures. Okay. Now sometimes you have to give your answer in 4 significant, sometimes you have to give your answer as correct to 3 significant. It depends on the question paper. So you have to pay attention on what level of accuracy you have to give. Now, one more thing. What about BC? BC equals to square root of 20. So that you have to use calculator, square root of 20. What is that? Also not very nice. Very long 4.472135955. And likewise, you have to give your answer in 4 significant figures. Start from the first non-zero number, 1, 2, 3, 4. Let's stop here. And then we have to check the next number. Again, it is 1 only, not big enough. So do we need to add 1 to the last number? No need, so we keep it as 2. No need to change. So your answer should be 4.472. This is also corrected to 4 significant figures. Let's stop here. So these are the values of AB and BC. Okay? So this is the Pythagoras theorem. And then in this chapter, instead of Pythagoras theorem, we have also learned one more thing, which is the opposite of the Pythagoras theorem. So what is that? The story starts from just a triangle. Please look at this triangle. Is it a right angle triangle? No, because we don't know anything about the angles. We don't have a right angle, obviously. So we cannot say that it is a right angle triangle. All right? But if there are 3 sides, A, B, and C, and you find that they have a special relationship, the longest one, so suppose this is the longest one, C is the longest one, among A, B, C, the longest one, you find that C to the power of 2 is just equal to the sum of the other 2 lengths square. A to the power of 2 plus B to the power of 2 is equal to C to the power of 2. If they are equal, they have this relationship, then we say that, oh, this triangle must be a right angle triangle. It is a right angle triangle. Okay? So you will see that it is just the opposite of the Pythagoras theorem. So because it is the opposite, we have to use another name. We do not call this Pythagoras theorem. We call this the converse of Pythagoras theorem. Okay, the converse means the opposites. So if you find that the 3 sides, they have this relationship, then it is a right angle triangle. And where is the right angle? The right angle must be the one oppositing to the longest side. So this one is the right angle. Okay? Now, let's look at some examples. So, let's look at this page. Look at number 7. In each of the following figures, you have to determine. So you have to judge. You have to judge whether this triangle is a right angle triangle or not a right angle triangle. So first of all, A, do you think that it is a right angle triangle? Do you think it is a right angle triangle? Yes or no? How to check? You have to check, not just guess. So that first of all, you have to find the longest length. 17, 9, and 14. Which one is the longest one? Of course, 17 is the longest one. So that you have to find 17 to the power of 2. You have to check what is 17 to the power of 2, the longest one to the power of 2. And on the other side, you also need to check the legs, the sum of the legs square. You also need to check what is that? What is the sum of the legs square? And you hope that these 2 guys are the same. If they are the same, that means they are the same. So the longest length to the power of 2 equal to the sum of the legs to the power of 2. Then we know that it must be a right angle triangle. So this is what we hope. We hope that it is a right angle triangle. So let's do it. Let's check. What is 17 to the power of 2? 17 to the power of 2, 289. 289. And then what about 9 to the power of 2 plus 14 to the power of 2? So 9 to the power of 2 plus 14 to the power of 2. What is it? 277. Alright, so do you think that they are the same? Obviously they are not. This is 289, this is 277. They are not the same. So 17 to the power of 2 doesn't equal to the sum of 9 to the power of 2 and 14 to the power of 2 because they are not equal. Therefore, it is not a right angle triangle. So this is our conclusion. It is not because they are not the same. Okay? But if they are the same, then our conclusion is different. If they are the same, they are equal, then it is a right angle triangle. Okay? So let's look at the second one, this one. Again, you have to check, is it a right angle triangle? So first of all, you have to pick the longest one out. Which one is the longest? Square root of 126, 10, or square root of 26? Oh, I don't know how to compare because there's a square here. I have no idea how big, how long is this length, how long is this length. I just know that this length is 10, but I have no idea. Then you don't worry, you can use your calculator to check. Square root of 126. Square root of 126 is 11.2. So this is 11.2 something. Very close to 11.2. Then what about square root of 26? Square root of 26, 5 point something, 5.09. 5.09. Very close to 5.09. So now, are you able to compare which one is the longest one? Yes, of course, 11.2 is longer than 10, longer than 5 point something. So 11.2, this one is the longest one. Therefore, we should consider the square of the longest one. And on the other hand, you also need to check the sum of the legs square, 10 to the power of 2 and square root of 26 to the power of 2. Okay? Now, for the upper side, square root 126 to the power of 2, anything that we could do to simplify them? We could cancel out square and square root, right? So that we have just 126 left behind. Okay? And then what about 10 to the power of 2 plus square root of 26 to the power of 2? Now 10 to the power, square root and square, we know that we could cancel them out. So we have 26 only. So that now we have 10 to the power of 2 plus 26. What is that? 10 to the power of 2 plus 26. 126. So, is it nice? They are the same. So we are so happy they are the same. That means square root 126 to the power of 2, square root 126 to the power of 2. Actually, it equals to 10 to the power of 2 plus square root of 26 to the power of 2. They are equal. This guy is equal to this guy. So you may draw a conclusion because they are equal. Therefore, it is a right-angled triangle. It is a right-angled triangle. And if it is a right-angled triangle, there must be a right angle. Can you tell which angle is the right angle? Angle P, angle Q, or angle R? It must be the one opposing to the longest side. So this one is the right angle. And if it is a right angle, you also need to tell people which one is the right angle. You may say angle PRQ. From P to R to Q, the middle one, this one. Angle PRQ is the right angle. Okay? So let's do one more. What about number 6? This one. So in this figure, you see that we have a triangle here, right? Is it a right angle triangle? No, we don't know it yet because we don't have any information about the angle here. We obviously don't have a right angle. So it is, we don't know whether it is a right angle or not. We have to check. First of all, you have to show that this triangle PEQR, is a right angle triangle. You have to show people that this is a right angle triangle. Can you do that? Right angle triangle. So how to show that? First of all, there are three sides, 10.9, 6, and 9.1, right? So we have to start with the longest one. This one is the longest one. So you have to check the longest one to the power of 2. You have to find what is it. And then on the other hand, you have to check the sum of the legs square. 6 to the power of 2, 9.1 to the power of 2, and then you also need to find the value. And you hope that they are the same. So let's see. Let's see whether they are the same or not. 10.9 to the power of 2, 118.81. And then the other one, 6 to the power of 2 plus 9.1 to the power of 2, 118.81. Oh, what a coincidence. They are the same. So 10.9 to the power of 2 equals to the sum of 6 to the power of 2 and 9.1 to the power of 2. Therefore, you could draw a conclusion because 10.9 to the power of 2 equals to 6 to the power of 2 plus 9.1 to the power of 2. And therefore, the triangle PQR is a right angle triangle. Right? Oh, this is a right angle triangle. So, which one is the right angle? Which one? P, Q, or R? Which one? The one oppositing to the longest length. This angle is the right angle. So that angle PQR, this angle PQR is the right angle. Okay, so part A is done. Let's look at part B. You have to find the area of this triangle. So do you remember how to find the area of the triangle? Base times the height. So as this is a right angle, if this is the base, then this is the height. So just base times height divided by 2. So area of this triangle equals to the base times the height divided by 2. This is how we find the area of a triangle. So 6 times 9.1 divided by 2, 27.3. 27.3. So the unit is cm, and for area, the unit is square. So that we have to use cm to the power of 2. This is the area of this triangle. Okay? So, now I would like you to be well prepared for the quiz, so I prepare you an exercise to do today. You have to work on worksheet 11, which is an overall revision. So the questions are similar to these examples. You have 1, 2, 3, 4, 5, 6, 7, and the answers are given at behind. Okay? So, try your best, be well prepared for the quiz on Saturday. Bye-bye.